Greetings to all of you. The session is regarding intermediate chemistry. We are going to discuss about the intermediate chemistry level. This is helpful for your international entrance and competitive exam you are preparing for. India level, JEE Advanced, JEE Mains, that will be helpful for IIT and NIT entrance examination is the technical domain. NEET chemistry, that is medical entrance exam across India. Telangana and Andhra Pradesh government are conducting MCET examination, that is the entrance into BTech engineering stream. And in addition, if you are preparing for any government organized examinations for the career opportunities, where general studies is the common question paper you can find. In that, general science content will be there. The session what we are discussing is very much fetching to your preparation. Let's enter into our today's session. The question 1, explain the isomerism of following compounds. So two compounds are provided where you can find carbon with R for alkyl, NH2, COOH, H. And same compound is given with another orientation. So both are the same kind of compound, but the thing is the arrangement is different. And these two compounds are said to be either diastereomers, enantiomers, homomers, metamers. What would be the correct answer? The expected answer is enantiomers. Let's see what is meant by enantiomerism in terms of isomerism concept. Before going to enter into that enantiomers, first of all, we have to know what is meant by isomer. Iso means what? Similar. The two compound resembles the same, right? The two compounds if contain same molecular formula, but differs in the arrangement. Okay, especially this is the product. Enantiomer is the product called kind of stereoisomerism. Stereoisomerism stands for where arrangement of functional groups are different. This is the content collected from liber text. In organic compounds, molecules are created around the chain of the carbon atom. And essential role in the chemistry of life because carbon plays a vital role. Carbon backbone is very important in most of the compounds. These molecules derive the importance from energy they carry, mainly from the potential energy between atomic molecules. They are accompanied by larger extent of energy, right? The concept of isomerism is put upon, and in specific stereoisomerism, the property of chirality is most important. Right. So if you go to study about the stereoisomerism, where the compound resembles the same, but only the difference is you have to change the position of the functional group. One of the compound is having right hand side, another compound may have left hand side, that same functional group. That is said to be what? Spatial arrangement. How they are arranged around that carbon atom is said to be spatial arrangement that matters for stereochemistry. Why? What happens if you are changing the position? If that interchange or positional change is possible, the properties of molecule entirely changes. So that stereochemistry plays a vital role in the depiction of molecule and in turn its application properties, right? So here Vantaff and Lebel are the scientists who developed the concept of stereochemistry, and chirality plays a vital role in the optical isomerism for these molecules. Chirality denotes what? Around the carbon if four different functional groups are located. If you observe, COOH is the larger lobe, and R is there called alkyl, and NH2 is there and somewhat smaller lobe, and hydrogen penny lobe will be there. So all four different functional groups are located around the carbon, so that we can say it is a chiral. Chiral means what? Any carbon having four different functional groups. Chirality is also called as asymmetric carbon. Okay. If you observe both the compounds, both are looks like a mirror reflection to each other. Right? If you put a molecule in front of a mirror, it looks exactly like any other molecule whichever present. So that both are mirror reflection to each other. If you put one molecule upon any other, what happens? So just like your two palms. So when two palms are taken, if you want to make a superimposability of one palm upon another, what happens? Both are non-superimposable. But what? So when you observe your two palms, what happens? One is the mirror reflection to another palm. right? So if you put a mirror over there, how it looks like a mirror image, in the same mirror image is your right hand palm, right? In the same manner, enantiomers also having mirror reflection relationship, and both are non-superimposable. Non-superimposability in the sense, if you take one of the molecule and put over another, both are not exactly mapping. Both are different side, so that both are said to be non-superimposable but mirror reflection to one another. That is said to be a enantiomeric pair. And these two molecules having the stereoisomerism, and in specific enantiomerism is mentioned. Homomers means both are exactly identical. Wherever OCOH is there, there only you have to put COH. Wherever R is there, there only you have to put R. Wherever NH2, there only NH2. And here hydrogen you can put. Then you can say both are homomers. Homo means same. But these are not homomers, rather both are enantiomers. If you see mirror reflection among both, that is called enantiomeric relation, right? Question number 1, answer number B is the correct answer. Move on to second question. It is collected from Cambridge Assessment International Education. Orange juice is acidic. They only gave the hint. Orange juice is acidic in nature. Draw the circle around the pH of orange juice. It's a very easy question they mentioned because the clue is given by themselves. So on the pH scale, very simple to understand. Nature of the compound. Nature of the compound is laying 0 to 14. 0 to 7, the compound is said to be acidic. At the 7, neither acidic nor basic, rather it is the neutral compound. Above 7 up to 14, it is said to be a basic. Okay. As pH decreases, strength of acid increases. As pH increases, strength of base increases. This is the way we can assign nature of the compound in accordance with the pH of solution. So among all the options, only one option is having less than 7 pH. Less than 7 pH is obviously acidic in nature. Orange juice is acidic, they mentioned, so blindly we can put a circle around this pH 4. So that pH 4 is the correct answer. And undiluted orange juice is said to be a pH 3.9. 3.9 rounded up as a 4. Orange juice distilled water diluted solution may have 4 pH. And the sodium hydroxide neutralized. If you are neutralizing, neutral solution always accompanied with the pH 7. So that pH 4 is the correct answer for what? Orange juice, right? So this is the entire table you can notice. So some solutions were taken, and take a strip of pH paper and insert into these juices so that you can understand which juice, what pH you can notice, right? So starting from the bottom, here is the lemon juice, which we can say lemonade. Lemonade is having the pH of 2. It is soaring in nature, right? Soaring taste is accomplished for what? Acidic nature. Okay, bitter taste for basic nature, right? So most of the acidic substances are edible. Most of the basic substances used as cleansing agents for detergents, for floor cleaning, for cloth cleaning. So cleansing materials are accomplished with a basic nature. Edible materials mostly accompanied by the acidic nature. If you see lemonade, whose pH is 2, and Coca-Cola, it is the soft drink, we can say 2.52 pH will be there. And grape juice, if you are taking that, pH will be 2.9. Pineapple pH is 3.2, right? 3.2. Then apple juice, if you are taking 3.30 pH will be there. Orange juice we have 3.69. Tomato juice is having 4.3. Sorry. So this is the way different pHs are mentioned, and orange juice having pH of 4. So for question number 2, option number 1 is the correct answer. Move on to question number 3. Question number 3 is collected from JEE Advanced 2018 question paper conducted on 20th Feb 2018, and paper 2 question related with the chemistry content, and it is purely of chemical kinetics. For a first order reaction, A gives rise to 2B and C. Starting material is A, so that we can say first order. Reactant is only 1. And the products are 2B and C. All are taken under gaseous conditions only. At constant volume, will not be changed. We are not supposed to change the volume, rather temperature, volume will not be changed, and the temperature also constant, that is 300 Kelvin. 300 Kelvin temperature was taken over there. The total pressure at the beginning T is equal to 0, and the pressure at the time T are taken as P naught. P naught is the initial pressure and PT is the at the time T, that is taken as a PT respectively. Initially, only A is present because just at starting only reactant will be there, right? So with the concentration A naught, so whose A is the initial reactant, whose initial concentration is designated as A naught. And at T 1 by 3, T half is nothing but T 1 by 2, but here T 75%. So time completed 75%, that is given by T 1 by 3 is the time required partial pressure A to reach 1 by 3rd of the initial value. Okay, 75% of the reaction got completed. The correct options to be identified. Assume that all these gases behaves as ideal. All are ideal gases. Means we are maintaining constant temperature, constant volume conditions as well, right? So for that purpose, the correct answers are expected to be A and D. Let's see how can we answer this. Okay. Here is the reaction. A is the gaseous reactant, and being it is the one molecule at initial condition, so that it will follow first order kinetics and gives rise to the product to be under gaseous, so it is in gaseous form, and C gaseous form will be there, volume kept constant, temperature kept constant at 300 Kelvin. This is the reaction process. At initial time, T is equal to 0, reaction not yet started. At that condition, initial pressure is taken as P naught. At a time is equal to T 1 by 3. T 1 by 3 means 75% time completed. So that the product formation will be 2 P naught by 3 and 2 P naught by 3 again for B. But 2 P naught by 3 can be multiplied with 2 again, because here 2 exponential is there. 2 multiplied with 2 will become 4 P naught by 3. I think it is more clear. At a time is equal to T 1 by 3. It is given as a product C is of 2 P naught by 3 will be formed. And B is also formed 2 P naught by 3 only. But here already one exponential is there, that is 2. So 2 P naught by 3 multiplied with 2, that will become 4 P naught by 3. Okay. So this extent of product formation is possible. But initially, the pressure of the starting material is P naught. But some extent got converted into product, right? So what extent product formed, that we need to subtract in order to get reactant concentration. Okay, being it is a gas, pressure will be taken. P naught can be subtracted with 2 P naught by 3. So P naught minus 2 P naught by 3. If you do this, we will get the concentration of A. That means pressure of A. Okay, so P naught minus 2 P naught by 3 will become P naught by 3. Okay, so this is about concentration. Then this is for what? Time is equal to T 1 by 3. I am going to apply T is equal to T only. T is equal to T means at a T time. T time means that may be half an hour, 1 hour, 2 hours, whatever it may be. I am taking a particular instance of time. At the time, the initial starting material is converted into some extent of product. I don't know how extent formed. So that I'm saying it is X amount of C will be formed. So if C is the X amount, obviously 2B will become 2X. Okay. So this extent of product is formed. Starting material will be some extent withdrawn, right? So that we can say P naught can be subtracted with X. X amount of products are formed already. So that X can be subtracted from P naught. P naught minus X is the pressure of A. A is the reactant. Okay. So what I am doing, PT is equal to, PT means what? At a time T, the pressure is given by, you can add all these terms. How can I add? P naught minus X plus 2X plus X. All these values can be summed up. You can sum up. Okay. When you're going to add all these, here negative X is there, here positive X is there. So that both get compensated. You can cancel out positive and negative terms cancelled. So the leftover will be Pt is equal to P naught P naught plus 2x, because minus x plus x cancelled out, no? So that P naught plus 2x, P naught plus 2x. Okay. So here Pt is equal to P naught plus 2x, you got it. So in order to calculate this 2x value, 2x is equal to at a time P minus at initial pressure. So pressure at the time T minus pressure at initial term. So this is Pt minus P naught. 2x is equal to Pt minus P naught. This value you got it. After getting this one, what they are saying, the reaction is called first order kinetics. For first order kinetics, the equation is time T is equal to 1 by K ln P naught by P naught minus X. P naught is nothing but initial pressure of the reactant, and P naught minus X is nothing but, so after T time, the concentration of starting material, that is P naught minus X. 1 by K ln P naught by P naught minus X can be taken. Then what I am doing, x value can be substituted. How can I substitute? 1 by K ln P naught remains P naught only. Here P naught remains P naught only. But x is equal to Pt minus P naught by 2. If 2 is coming this side, that will become denominator. So that P naught minus Pt minus P naught by 2. Right? So this is T. T means at time T. Okay. So here what we have, denominator 2 value is there, so that it will go up and it will become numerator. So let me put 1 by K ln 2 P naught by 2 P naught minus Pt plus P naught. Negative, minus into minus, it will become positive, right? So let me repeat again. A time T is equal to 1 by K ln 2 P naught by 2 P naught minus Pt plus P naught. So this is the value I got. After getting this one, what I will do? Here 2 P naught is there, here P naught is there. So same terms, right? So that you can add up. Whenever these two terms are added, that value will become, so here K is there as a denominator. So take this K left hand side. It will become KT. KT is equal to ln 2P naught by 3P naught minus PT. Right? KT is equal to, KT is going left hand side. So that ln 2P naught by 2P naught, P naught will become 3P naught minus PT. 3P naught minus PT. Then denominator, if you are going up, if you are taking denominator term as the numerator, what happens in the logarithmic value? The value will become negative. So that let me write the final equation. Kt is equal to ln 2p naught minus ln 3p naught minus pt. This is the final equation. From this, I want to get this pressure term. I am going to take this pressure term left hand side, so that ln 3p naught minus pt, negative value there, so that whenever you are going the left hand side, it will become positive. Ln 3p naught minus pt is equal to, kt is coming right hand side, positive will become negative, negative kt plus ln. Sorry for the disturbance. Let me continue. And the final equation will become ln 3p naught minus pt is equal to negative kt plus ln 2p naught. This is the equation is looking like y is equal to mx minus c. Y is equal to mx minus c is if present, there is a slope, negative slope will be there. Time versus ln 3p naught minus pt if taken. Here you can find a negative slope that is purely mentioned in option A. This is perfectly correct. After the derivation, we got it. The equation is in the form of y is equal to mx minus c. But if this is correct, C will become wrong because both are looking same. Here they are taking ln p naught minus pt versus time. There is a negative slope. This is wrong only because after the derivation we got this relation only. A will be correct one. Move on to B. Let's check about B. In order to calculate about B, so T1 by 3. T1 by 3 means reaction, sorry, time accomplished 75%. So for example, if the reaction is completed, in 1 hour, if reaction is required to be completed in 1 hour, what I am saying, 75 minutes, sorry, 75% completed in that. So 75% time if completed, then what I am saying, so 15 minutes, 15 minutes, 15 minutes, 15 minutes. For 15 minutes if present, then only we can say 1 hour. Okay. 30 minutes, 30 plus 15, 45 minutes if completed, that is called T1 by 3. If the reaction is completed in 1 hour, so I am saying 75% time completed. That means 45 minutes time completed. So that is called T1 by 3. Okay. So T1 by 3 is equal to, the formula will be 1 by K ln P naught by P naught by 3 can be taken. Okay. So here P naught is there in the numerator, P naught is there in the denominator as well. P naught get compensated. If you cancel out denominator, so that let me take up this 3 upside. So numerator, P naught cancelled out, no? So that ln 3 only left. 1 by K ln 3. T 1 by 3 is equal to 1 by K ln 3. This is the value I got. If you observe this relation, it is independent of initial concentration. There is no initial concentration effect. But in option number B, what they are saying, as time passes, when we are taking T1 by 3 on the Y coordinate and initial concentration on the X coordinate, as the concentration is moving, as the concentration is increasing, T half is decreasing, they are saying. But as per this equation, there is no relation between the initial concentration and T1 by 3. So that what they are saying in the option B, you can cancel out. Option B is wrong, C is wrong. A is correct. Just now we got it. Move on to last one. As the rate constant is a constant quantity and independent of initial concentration, graph D is correct answer. In the graph D, what they are saying, rate constant was taken in the Y coordinate, initial concentration was taken in the X coordinate. This is exactly applicable for the first order kinetics. Rate constant is giving negative slope with the initial concentration of the reactant. This is the slope given for first order kinetics, and they are saying first order kinetics, so that we can put a tick mark over there. For question number 4, A is correct, D is correct, B is wrong, C is wrong. This is the way we can answer. In order to answer this question, chemical kinetics fundamentals are very important to be learned. Then only it is possible to solve such kind of questions. Move on to question number 4. JEE Advanced 2019 question paper 1 question it will be, right? So here the question is, अमोनियम सल्फेट की कौशलियम कैल्शियम एनहाइड्राइड के साथ विवेचन करके बनाए गए अमोनियम को निकल डाइक्लोराइड हेक्साहाइड्रेट द्वारा पूरी तरह से एक स्थिर उपसह संयोजन यौगिक, उपसह संयोजनी यौगिक इज नथिंग बट कोऑर्डिनेशन कंपाउंड बनाने में उपयोग किया गया। मानिए कि दोनों अभिक्रियाएं 100% पूर्ण है। यदि 1584 ग्राम्स अमोनियम सल्फेट और 952 ग्राम्स निकल क्लोराइड हेक्साहाइड्रेट इस विरेचन में उपयोग किए गए हैं, तो इस प्रकार उत्पादित जिप्सम और निकल अमोनियम उपसह संयोजक यौगिक का संयुक्त भार कंबाइंड वेट ग्राम में है। परमाणु भार ग्राम पर मोल में हाइड्रोजन 1, नाइट्रोजन 14, ऑक्सीजन 16, सल्फर 32, क्लोरीन 35.5, कैल्शियम 14, निकल 59. ओके, अमोनियम सल्फेट और कैल्शियम एनहाइड्रेट. Okay, these are the reactant to be taken, and the question is about whatever final product we are getting. What are the final product? One is gypsum or nickel ammonium Saha samyojani yogik. Both the compounds can be taken together. Their weight, combined weight to be calculated. Right? In order to get that question, two formulas are most important. One is about mole formula, calculation of moles, and second is how to calculate weight if you know the moles. So these two are the fundamental formulas to solve this question. One is number of moles is calculated as weight by gram molecular weight. Then if you want to calculate the weight, number of moles into molecular weight. So both are same only. So if you know the moles, weight, you want to calculate what happens. Weight is coming this side, moles can be multiplied with molecular weight. If you know the weight, moles is calculated by taking weight by gram molecular weight. So both are same formulas only, but both are required, right? Number of moles is equal to weight by gram molecular weight. Weight is equal to number of moles into molecular weight. If you know this, it is obvious to calculate the problem. First of all, we have to solve the chemical equation, right? So they are saying calcium hydroxide. Calcium hydroxide and ammonium sulfate. Ammonium sulfate weight is given within the problem. How much weight? 1584 grams of ammonium sulfate is given. Whenever both are reacted, 2 moles of ammonia will be formed and calcium sulfate dihydrate formed 1 mole. Most important to remember, let me repeat again. Calcium hydroxide and ammonium sulfate when treated, 2 moles of ammonium, 1 mole of gypsum is formed, right? So here the formed compound further treated with nickel hexaaqua chloride compound. This is called hexaaqua nickel chloride, hexaaqua nickel 2 chloride in specific. Okay, so whenever this is treated, we will get a Sankul yaugic, means a combined compound will be formed. Sankul yaugic means what? Combined compound will be formed. Whenever this is the chemical reaction, now we are going to calculate what will be the mole, what will be the weight. First of all, let's go with this known compound. Ammonium sulfate is known to you, right? So ammonium sulfate के मोल की संख्या निकालने के लिए weight is given. Gram molecular weight of ammonium sulfate is 132. Weight by gram molecular weight. Just now we saw mole formula, weight by gram molecular weight. Weight is given as 1584 grams. Molecular weight of ammonium sulfate is 132. So that you will get 12 moles. How much? Ammonium sulfate is of 12 moles. Okay. So, निष्कासित ammonia के मोल. Ammonia, how many moles formed? 2 moles. 1 mole of ammonium sulfate gives rise to 2 moles of ammonia, right? Then 12 moles of ammonium sulfate gives rise to 24 moles because double you have to do the quantity. So that 12 moles gives rise to 24 moles of ammonia because we have 2 coefficient, right? So 2 multiplied with 12, that will become 24 moles. Okay. Now, this is the compound which is hexaaqua nickel 2 chloride. So, hexaaqua nickel 2 chloride के mole calculation. So weight is given as 952 within the problem. 952 grams of nickel chloride hexaaqua is given. 952 is the weight of this nickel chloride hexaaqua and its molecular weight is calculated as 238. How to calculate molecular weight? Sum of all the atomic weights is called a molecular weight. 952 by 238. How many moles you got? 4 moles. Okay. 4 moles of nickel chloride hexahydrate will be used. Okay. So if you know this, if 12 moles of ammonium sulfate is used, obviously 12 moles of calcium sulfate dihydrate will be formed. If it is 12 moles, ammonium sulfate is 12 moles, calcium sulfate dihydrate is also 12 moles only. Okay, so 12 moles is clear to you. Now, if calcium sulfate dihydrate is 12 moles, what is the amount of calcium sulfate dihydrate? Weight is required to be calculated. So, निर्मित जिप्सम का द्रव्यमान बोले तो it's weight. So weight is equal to number of moles into molecular weight. Number of moles is calculated as 12 and molecular weight of gypsum is 172. Molecular weight of gypsum is 172. So 12 multiplied with 172, you got a 2064 as a weight of gypsum. Gypsum weight is 2064. They're asking for the combined weight of these two, right? So that, so Nirmit Sankul ka Dravyaman, Nirmit Sankul ka Dravyaman, how many moles of nickel compound is there? Nickel compound number of moles are 4. What is the molecular weight of nickel compound? Molecular weight of nickel compound is 238. So that 238 multiplied with 4, we will get 928. 928 grams of nickel chloride hexahydrate will be there. Okay, they're asking for Sankul Yaugic. A combination weight is required, so that let's add 2064 can be added with 928. 2064 added with 968. The total will be 2992 grams. This is the final answer. 2992 grams we will get. For question number 4, 2992 grams is the correct answer. Move on to question number 5. Question number 5 is collected from organic chemistry, and moreover, this is the question from Telangana MSET examination, which is conducted in the year 2023. The correct stability order for the following resonance structure is. క్రింద ఇవ్వబడిన రెజోనెన్స్ నిర్మాణాల సరైన స్థిరత్వ క్రమాన్ని గుర్తించండి. Okay, resonance structures are nothing but what we are doing whenever pi bonds are present, pi bonds having natural tendency move from here to there to here, like that delocalization of electrons is called resonance. Whenever electrons are delocalized, one more new structure will be formed. Again you are moving, so that new structure, this is the way, as the electrons are moving, a new structure will come. More the resonance structures, greater the stability for the given compound. If these are possible resonance structures for this compound, the starting material is called what? Proptoene 1 all. All means aldehyde is there. On second carbon double bond is there. I can say proptoene 1 all, right? So this is the compound, and it will participate in resonance, so that we will get three many forms. Three many forms are possible in the second one: carbon acquiring negative and oxygen acquiring positive. And the third one, carbon acquiring positive and oxygen acquiring negative. These many possibilities, if present as a resonance structures, they're asking for their comparative stability. Obviously, uncharged conjugated system will be more stable. Option 1 is given in 2, so there is a ambiguity. Later on, 3 can be taken and 2 will be the least one. So we will explain why 1 is taken first, 3 is taken next, and 2 is taken least. Okay, the expected answer is option number 4. Let's see how can we explain this answer. In order to explain this one, resonance, we have to know the concept about resonance. Resonance is called what? Delocalization of pi electrons, or else non-bonded electrons also sometimes will participate. Okay, if you see this molecule, this is called a proptoene 1 all. So this is the one where you are moving the pi bond toward this side, being it is a conjugation. Conjugation means what? If any double bond and any other double bond, both are alternatively arranged, and saturation is in a alternate arrangement. Double bonds are in alternately arranged, so that this pi bond is moving towards this side, this pi bond is moving. Whenever pi bond is moved, here new double bond will be generated, and this carbon is acquiring positive. The terminal carbon is acquiring positive, and this terminal oxygen is acquiring negative, because it is taking electrons, no? So in comparison to this uncharged, obviously charged particle will be least stable. This will be least stable, we can say, comparison. And one more possibility, let's turn all the heads. Okay, so here this pi electrons are moving this side, right? Now what I am doing, this is moving in reverse direction. This pi bond is moving this side, and this pi bond is moving this side. At that condition, carbon is gaining electrons, so that carbon will get negative, and here the new double bond will be generated, and these electrons lost by the oxygen, so that oxygen positive. Okay, this is the The condition number 2, this is the condition number 1, this is the condition number 3. Obviously, uncharged one will be more stable, that is already confirmed. Now, there is a ambiguity between this structure 2 and structure 3. How can we say this will be second one and this will be third one in the stability order? Because anyone can say, if you compare the electronegativity of the carbon and oxygen, which is electronegative atom, obviously oxygen is electronegative atom, having strong tendency to hold its electrons. That's the reason why oxygen is more favorable to carry the negative charge, but not positive charge. Carbon having tendency to get the positive charge, but not negative charge. So oxygen accompanied by the negative charge is more favorable in comparison to oxygen positive charge. So that I'm saying this compound, this resonance structure is having second most priority, and this oxygen positive is least priority, least favorable for oxygen. It will not hold the positive in the maximum extent. So that I'm saying obviously of uncharged will be the higher stability, and the next will be O minus. Oxygen carrying negative is somewhat stable, and oxygen carrying positive is highly unstable, so that I'm putting this second resonance form at least stability. So that first order will be compound number 1, and the compound number 3 will be the second, and compound number 3 will be the third one. For question number 5, option number 4 is the correct answer. Move on to question number 6. This is the last question of the session, and it is related with again organic chemistry, and it is the kind of distinction between the propyne and the propene. Which of the following reagent can be used to distinguish propyne from propene? Both are related with the 3-carbon chain only. Propyne is of 3 carbon, propene is also 3 carbon. But propyne is accompanied by the triple bond, propene is accompanied by the double bond. How can you distinguish triple bond from double bonded compound? ప్రొపైన్ ను ప్రోపీన్ నుండి గుర్తించడానికి ఈ క్రింది వాటిలో ఏ కారకాన్ని ఉపయోగించవచ్చు? Okay, so it's purely relying on the reagents. That means a chemical test for the distinction between the propyne and the propene. How can we identify? There are the options: bromine dissolved in CCl4, dilute CaMnO4 at 273 Kelvin temperature, Sajila CaMnO4 273 Kelvin temperature vadda, ozone dissolved in ozone in combination with zinc water, zinc metal and water condition, sodium dissolved in liquid ammonia. దీన్ని ఏమనొచ్చు? సోడియం ద్రవ అమ్మోనియాల సమక్షంలో. ఇవన్నిట్లలో వేటి ద్వారా మనము ప్రోపైన్ ని ప్రోపీన్ ని రెండింటిని సెపరేట్ చేయొచ్చు. సో ఒకటి ప్రోపైన్ అని ఒకటి ప్రోపీన్ అని మనం ఈజీగా గుర్తించవచ్చు. ఫర్ దట్ పర్పస్ ఓన్లీ ద పాసిబిలిటీ ఈజ్ ఆప్షన్ నెంబర్ డి. That means sodium in liquid ammonia will use to identify propyne from propene, but remaining all are common for both. Both will react with these many reagents. D will not react with one of the reagents. Let's see in detail about this reaction. Okay, bromination. What is the purpose of bromination? Bromine dissolved in CCl4. CCl4 is called carbon tetrachloride. Carbon tetrachloride is the solvent in order to dissolve the bromine. Whenever this bromine is added to any of the double bond, what it will do? Double bond will be added with the bromine, so that addition product, dibromo product will be formed. This is the addition reaction, which is the test for unsaturation. What bromine test is very specific for. I'm checking the unsaturation. If the compound is unsaturated, bromine test is positive. Bromine color will be disappeared. Bromine color will be disappeared. If color disappear, what I can say? The given compound is unsaturated, either double bonded or triple bonded, both will give. So this propyne will give positive test with bromine water or bromine CCl4. Propene will give the positive test, so that I can't identify which is propyne, which is propene, because both are reacting with the bromine in CCl4, so that I can't identify. Move on to another test, which is called permanganate test, which is also called as Bayer's test. Take the compound added with potassium permanganate. Purple color liquid is added to the unknown solution, which don't know. So here color changed to brown. So if color changed to brown, What you identified, the given compound is having double bond in that positive test. This is the positive test. So that I can say there is a double bond in the compound. So if compound is not changing its color, there is no double bond or triple bond in that. Okay. So if you are going to do this Bayer's test, propine will change the color and propane will change the color. That means both will react with Bayer's reagent because both are unsaturated. Again, it is a test for unsaturation. Alkyne is unsaturated, alkene also unsaturated. So that both are reactive, both are positive towards Bayer's test. So that I can't identify which is propine, which is propene. Move on to third test. I'm going to add ozone. Ozone is the allotrope of oxygen. Whenever ozone is added, wherever double bond will be there, the double bond get cleaved. And you will get aldehyde at one place and aldehyde at another place as well. So wherever bond cleavage, there you can find two carbonyls. And upon treating with zinc dust water, we will get aldehyde like this. This is the ozone treatment, also simple test to identify where the double bond is present. So where the double bond is there, there the cleavage you can notice either double bond or triple bond. Triple bond also will broken and you will get such kind of aldehydes over there. Okay. So propine will go for ozone test and propene also go for ozone test because both are unsaturated. So this ozone treatment is also identification of unsaturation, but not to propine, propene. Propine, propene, both are unsaturated. So that what I'm saying, both will reacted, both are positive only. So I can't notice which is propine, which is propene. But there is a reagent called sodium in liquid ammonia. Whenever propine is treated with sodium in liquid ammonia, I got one propene. One propene is formed. But I'm taking propene and treated with sodium in liquid ammonia, but there is no reaction. Reaction may not be feasible. One is reacting in specific, it is converted into double bonded, but another will not be reacted. So that I can identify. Propine is giving positive reaction and giving a propene molecule, but propene is a negative, it will not be reacted. So I found the fact, I identified by means of this sodium dissolved in liquid ammonia. One is reacting, one is not reacting. So that I can say this is the distinguishing test. When sodium dissolved in liquid ammonia, whose boiling point is negative 33 degrees centigrade, turns a deep blue color. In the presence of alkynes, they are reduced to transalkenes. This is specific for transalkene formation, right? So this is the way positive test is given by propine, negative test is given by propene. Propene will not react over there. So that what I am saying, so sodium in liquid ammonia is a suitable reagent for the identification of propine from propene. One is reacting and other is not reacting. Only D is the right reagent to distinguish. Okay. For question number 6, option number D is the correct answer. By this, the entire session was completed. Hope the session is very informative, very lengthy one, and a small fluctuation we got over there. And anyway, we covered the entire thing with the detailed explanation, with the clear and authentic matter. Hope the session is very important for your preparation. Those who are preparing seriously, the kind of session, the series of sessions what we are making will be really helpful. Hence, I'm sincerely requesting to like the channel, comment which part is really important for your preparation, and share with as maximum as possible with the aspirants who are serious about the examination. Subscribe the channel. We will get more such kind of videos in the near future so that you will get continuous updates over there. Thank you very much for your patient listening. Thank you one and all.